Good day, everyone. We are Group 2 of Grade 11 Owen. Our objectives for today's lesson is history of anti-differentiation, application in Mindanao context. For solved problems, we have basic anti-differentiation rules, algebraic example, chain rule, general power rule example, trigonometric example, and exponential or logarithmic example. Tips for future basic calculus learners and references. Let us all do our best to learn as much as we can, respect and support each other through all the challenges, and appreciate basic calculus.
Good day, everyone. We are going to present the history of antidifferentiation. Antiderivatives are the opposite of derivatives. An antiderivative is a function that reverses what the derivative does. One function has many antiderivatives, but they all take the form of a function plus an arbitrary constant. It is a key part of indefinite integrals. An improper integral has at least one infinite limit or has an integrand function that is infinite somewhere in the interval of integration. If an improper integral has a finite value, it is said to converge. Otherwise, it is said to diverge.
It was independently discovered by Newton and Leibniz in the late 1600s, and it establishes the connection between derivatives and integrals, as well as providing a method for quickly calculating many integrals. It was a key step in the development of modern mathematics to support the rise of science and technology. Mathematical methods can sometimes be used to transform an integral into more easily computed form. Numerical methods exist to compute accurate approximations to integrals that cannot be performed mathematically. So these are the portraits of Isaac Newton and Gottfried Wilhelm Leibniz.
Real-life application of antiderivatives and the fundamental theorem of calculus are useful in Mindanao for a variety of purposes, especially determining how much things grew over time. This theorem has business applications. For example, Netflix, a popular movie and television streaming service established in 1997. If we wanted to know how much money Netflix earned between 1997 and 2019, we could use the calculus fundamental theorem to calculate how much they earned in 1997 to 2019. Second example, in Mindanao, our engineers can use antiderivative in the engineering and manufacturing industries to determine the usefulness of a specific procedure and method of approach when assembling an item and the expected end result. This is primarily done during the problem analysis and evaluation stage. Last example, our medical industries here in Mindanao can use antiderivative to trace the generation and degeneration of disease causing bacteria, germs, and viruses. And if a study is conducted based on the observed pattern and behavior and the results finding pharmaceutical industries can develop a cure for the said disease causing organisms.
Now let us move on to the problem solution sets. So first, let's try solving a basic anti-differentiation problem. But what is anti-differentiation? Well, anti-differentiation is the reverse process of finding a derivative. Or in simple terms, we are trying to find the origin of a derivative. But to truly understand this concept, let us have an example. So here we are trying to find the antiderivative of x squared plus 2x plus 1. So how do we do this? Well, just like in differentiation, anti-differentiation, anti-differentiation also has a set of rules that we could follow in order to solve it. So for the antiderivative of x squared plus 2x plus 1, for the first value of x squared, we can use the power rule and it will become x to the power of 2 plus 1 over 2 plus 1. And for the second value of 2x, we can use both the constant multiple rule and the power rule, and we will get 2 times x to the power of 1 plus 1 over 1 plus 1. And finally, for the value of 1, using the constant rule, it will become x. So, next, we need to simplify it. So, the x to the power of 2 plus 1 over 2 plus 1 becomes x cubed over 3 plus 2 times x to the power of 1 plus 1 over 1 plus 1 becomes 2 times x squared over 2. Then x remains as x. And finally, we will get the final answer of x cubed over 3 plus x squared plus x plus c.
So for the general power rule, we'll have the example of integral of x plus 4 to the power of 9 dx. Use the previous formula, then let u be equals to x plus 4, so du is equals to 1 dx. For the solution, we'll have integral x plus 4 to the power of 9 dx is equals to integral x plus 4 to the power of 9 1 dx. So for that, we'll have the integral u to the power of 9 du is equals to u to the power of 9 plus 1 over 9 plus 1 plus c. Perform the given equation, and it will be equal to u to the power of 10 over 10 plus c. For the final answer, we'll have 1 to the power of 10 x plus 4 to the power of 10 plus c.
Good day, everyone. Today we are going to talk about the chain rule of trigonometric. So the first step on how to solve this problem is to assign the variables. So let u equals 5x plus 3. So du equals 5 dx. Next is to solve for dx. So the equation would look like du equals 5 dx. To get the dx, divide 5 on both sides. So the value of dx would now be du over 5. Since the values of u and dx are now solved, we can now substitute it in integral of function tan of 5x plus 3 dx becomes function of tan of u of du over 5. Now that is substitute, multiply 5 on both sides to eliminate 5 on the right side of the integral. After that, get the antiderivative of tan u of du, which is integral of sec u plus c. Substitute the value of u in the integral, so the answer is 1/5 integral of absolute sec of 5x plus 3 plus c.
Hi guys, today we'll be solving for antidifferentiation for logarithmic and exponential solutions. What is an antidifferentiation? It is the reverse process of differentiation. An example here is x to the power of 2 and its derivative is going to be 2x. The reverse process of 2x is going to be 2x equal to x to the power of 2 plus c. So you have two types of antidifferentiation, a direct u substitution and indirect u substitution. But first, we're going to be doing the direct u substitution. We have 4x to the power of 3 times e to the power of x to the power of 4 plus 4 times dx. So our u is going to be 4, which is going to be the more complicated variable. It's going to be x to the power of 4 plus 4. And our du is going to be the derivative of x4 plus 4. So it's going to be 4x to the power of 3. So that's why it's called direct u substitution, because the u and the du are related. So now we're gonna swap up the variables. It's going to be 4x to the power of 3 times e to the power of x to the power of 4 plus 4 times dx is equal to e to the power of x to the power of 4 plus 4 times 4x to the power of 3 times dx. Now we're going to be using theorem 3.a, which is eu times du. So e to the power of u plus c, because du is our constant and the label for our constant is c. So we're going to swap out u with the correct variable, which is x to the power of 4 plus 4. So we have e to the power of x to the power of 4 plus 4 plus c. Now we're going to be doing our indirect u substitution. It is called indirect because our u and our du are not related at all. So we have 5 times e to the power of 3x times dx. So we have u, which is going to be our 3x, which is 3x. Now for our du, we are going to find the derivative of 3x, e to the power of 3x. So it's going to be 3 dx. But now we're going to find for dx. So dx, so we're going to cancel out 3 from 3dx, so we could get dx. So we have du over 3 is equal to dx. So now we have 5 times e to the power of u times du over 3, and is equal to 5 over 3 times eu times du. So now we are going to substitute the variables. So we're going to have 5 over 3 with the integral of e to the power of 3x plus c. So that's our final answer. I hope you've learned something today, and I hope I'll see you next time. Goodbye.
So, tips for future basic calculus learners. To fully grasp the concept of calculus, whether pre, basic, or any other different forms of calculus, it's always mandatory to listen. Listening and understanding are the most fundamental things to hold on to, especially when dealing with math-related subjects. Firstly, learning the basics of basic calculus, such as the substitution and graphing, since these basics are what we would be doing in finding limits and in much more complex topics related to basic calculus. Another tip would be rechecking your answers, as one mistake is a crucial hindrance to the entire solution. This does not only apply to solutions, but to graphs as well. Lastly, in a difficult subject like basic calculus, you need to understand how and when to be patient, as your mental capacity is very important before anything else. Not getting the answer as soon as you start one solution may be very frustrating. That is why this requires a lot of focus and patience. Basic calculus may be easy for others or may be hard for some, but always remember we stand on our own feet. So take it step by step, just like the solutions.
These are our references for this video. Thank you very much for listening.